Twinthesis is a Twitter-powered additive and granular synthesis engine. The idea behind Twinthesis was to explore the sound of Twitter, to harness the potential of the human randomness being generated on the service. Twitter has over hundreds of millions of users worldwide, a figure which is expanding at a rate of about 300,000 users a day. These users are submitting on average around 90 million tweets per day. There's a huge amount of data there, ready to be sonified and turned into audio. Twinthesis is a MaxMSP patch that extracts the most recent public tweet and deconstructs that information in order to generate sound. Several pieces of data can be taken directly from the tweet, including the length of the tweet and the actual letters within the tweet itself. These letters are converted into a numerical value between 0 and 255, which is used to feed the oscillators for the additive synthesis part of this engine. The number of oscillators is controlled by the length of the tweet, so the timbre of the sound is directly related to the amount of information contained within a tweet. Because the ASCII characters contained within the tweet are often only going to be from the standard alphabet, the engine computes some pseudo-random values to multiply with the direct value of each letter, otherwise the harmonic range would be from 0 to 255. Multiplying the direct value with a pseudo-random value expands the harmonic range of the output to include very low frequencies through to very high frequencies. The first fader in the engine controls the level of this additive synthesis output, which acts as a bed for the rest of the sound. The second fader controls something called the twittering effect. This takes the outputs of the oscillators used for the additive synthesis and selects an output using a pseudo-random generator to play. This whole method is linked to a metronome, giving the user control over the speed of these changes, creating a twittering effect. The pseudo-random generator is actually seeded by the value of the length of the tweet as well, so this is directly influenced by data from Twitter. The next four faders control the individual granular synthesis engines within the patch. These engines are only a basic form of granular synthesis, but they take a very short sample from a set of given audio files and load this into a buffer, which is played repeatedly to generate the granular effect. The buffer size is directly related to the length of the tweet as well, which generates an interesting effect. So if the tweet is short, the granular synthesis will be slow, but if the tweet is long, the granular synthesis will be a very fast effect. Each of these channels within the synthesizer has parameters to control reverb, which is actually implemented using the FreeVerb MaxMSP external object. The background pad additive synthesis component can also be put through a vibrato unit purpose-built for this project, to add another dimension of control to the user. The Twitter synthesizer is an experimental way of sonifying the data that can be pulled from Twitter. With this implementation there is an element of musical performance, as the user can mix from 6 different textures and apply and manipulate reverb and vibrato effects on the fly. Currently, the Twitter synthesizer is only using the public API, so is restricted to calls once every 30 seconds. So every 30 seconds the synthesizer will load a new tweet, as shown to the right of the patch. But plans to develop this further could lead to the synthesizer calling Twitter multiple times a second and following individual user accounts, which introduces the possibility of an instrument or synthesizer being controlled instantly by over hundreds of millions of people anywhere in the world, a truly collaborative instrument. So that was an overview of the Twinthesizer. More information can be found on my portfolio website and blog, samharmon.com. Thank you for watching, I hope you enjoyed it.